And welcome back to our Advanced Developer Program. So we finished up our little keynote thing this morning, and so now we're diving right into the technical content, the technical meat of things. And so our first session, virtual switches and routers in LOD with Kirk.
Thanks, Corey. I got to say something about the session. This is a session that when you asked me to talk about it, I was a little bit intimidated because of just, I'm a software developer background, and so dealing with networking and routers and switches was intimidating to me, but I love this, and this has got a lot of command line stuff and DevOps, and I'm into PowerShell and things, and so this was right up my alley. It ended up
This is the
really
most excited I've ever seen you.
It's a really, really cool topic, so I'm happy to share this with you guys. I think it's going to be interesting for a lot of you. So virtual routers and switches in LOD is interesting because, I mean, before getting into a topic like this and looking at teaching advanced networking, for me, dealing with networking was often working in setting up a lab environment in Hyper-V, where I deal with the virtual switch in Hyper-V. And I don't really have to think too much about routing and whatnot, but obviously if you're going to be going after Cisco certifications and trying to help students learn that kind of an environment, they need to understand and be able to configure routers and to be able to set up fault-tolerant networks and be able to do all of that kind of advanced stuff that is important to their work, to their livelihood. And so this is all about how you can set up people, how you can get them started down that path. And so what's really cool about this instead of LOD is virtual network routers. They can be added into a lab in LOD just like you could add a normal Windows VM or a Linux box. It's just another virtual machine, but it's just representing hardware, 100% virtualized, and then you can talk to it just like you might talk to a router over the network once it's all set up. So you can set up these environments with your routers and configure your switches and set up your subnets and get all of that laid out the way you want. And then students, you can actually configure the lab environment so students can change the configuration to make networks work, to deal with issues when something goes offline. What do they have to do to bring that back online again? And you can control as little or as much as you want the students to configure. So you can get down to the per virtual switch level, which ones you want available for students to see. So which NICs you want them to be able to modify inside of their lab environment, and then they can hook those up into your network and make the network work the way it's supposed to.
Most labs we've dealt with deal with configuring operating systems.
Right.
So configuring Windows or Linux. What you're doing in here now is you're configuring the switch operating system, is that it? Or?
Yeah, so in this case, it's the router operating system. So one of the examples I'm going to show you is there's a virtual router by a company called MikroTik, and they use Router OS, which is based on Linux. And so you're configuring the router by talking to it just like, I mean, if I'm at home and I'm configuring my router, I go over the web to my router's IP address, and I log in, and then I can configure the router for the network. This is the exact same thing, but it's virtualized hardware, not talking to a physical box.
So you're doing like shell sessions and stuff?
Yeah.
Which is right up your alley.
Yes.
All right.
So I can go on the box and I can work with it directly through the shell session, or I can use in this case, there is a Windows client that you can use to actually connect and then get into a user interface and work with it from there. And yeah, so you can also get into much more advanced scenarios beyond this. Like what I'm going to show you is how you can configure this virtual router environment inside of a lab. And then you can go beyond that, where sometimes you might want to do some networking that requires you to have access to the hypervisor. And I'll talk about that because our platform supports nested virtualization, which allows you to have your own hypervisor that you can actually work with and configure and install stuff on. Normally you wouldn't be able to get to that level working with the hypervisors that we have in our data center, but this, because of nested virtualization support, you can go one level deeper and get to that level, which gives you even more advanced network scenarios.
The nested virtualization is something that we've had in our VMware stack for a while.
Yes.
With Windows Server 2016, we've now got it in our Hyper-V stack as well.
Yes.
And so that's, brought in a few new scenarios to the table.
Mm-hmm. Absolutely. So some examples, I already mentioned one of the names here. So when you're dealing with virtualized networks, I mean, there's a lot of them out there. I just threw a few in here to get you guys some things to look at if you want to look at what different things you can work with. So MikroTik is one I mentioned, which uses Router OS. There's pfSense. They use FreeBSD. for the operating system, but that also has router and firewall and VPN and all sorts of different cool things, DHCP and different stuff you can set up. And of course there's Cisco. Cisco's been around for such a long time and has a lot of things available that you can use. And then on the virtual switch side, you can access the native Hyper-V virtual switches and make those available for students to select when they're configuring the actual NICs inside of a VM. But there's also other virtual switches you can use, such as Open vSwitch, which allows you to work with OpenStack on top of Hyper-V. And if OpenStack's important to you, Open vSwitch can be installed on the hypervisor, and that's an example where the nested virt situation comes to play. And I'm sure there are others. These are just some examples that I've been looking at and poking around with.
And so these all operate in virtual machines?
Yes. Yeah.
Okay.
Open vSwitch you would install on a Hyper-V box, but virtualized, so the nested virtualization.
Yeah, so you could install, so you could have a lab that has Hyper-V, a VM running Hyper-V.
Yes.
With running Open vSwitch.
Yes.
And so now you've got this level of configurability that has been very difficult to achieve in the past in a replicable, is that a word?
Yes.
Replicable?
Yes, I think so.
I think it is now. In a replicable state, right? So I can go, hey, give me 100 of these, go, and it makes you 100 of them.
Yep.
And you don't got to worry about conflicts or hardware, so it's phenomenal. Awesome.
Absolutely. So because this is an advanced talk and a technical talk, most of this is going to be demo. I just kind of wanted to give you an intro of where we're going with this. So the demo I'm going to show you is learning networking with virtual routers and switches inside of a lab. And I have a lab environment set up. And let me show you what that looks like. So I'll talk about the configuration of this after I go through the initial lab setup and introduction to show you what things look like.
Will you push the lab full screen? There you go.
Perfect. So what I'm looking at, I'm going to get my PowerShell session here open because I love PowerShell. But
dude, love it. You're obsessed with it.
So this is just a typical Windows box. Actually, let me back up for a second. Before I talk about the VMs, I'm going to show you, I've added to this lab environment a network diagram so that if you're working with students and they need to know what the setup is and the topology so they can configure the network appropriately, you can load a network diagram into place.
So this is something, by the way, that has been in the platform for years. Very few people actually take advantage of. But this notion that you can build an elaborate diagram, whether it's like a topology like this, whether it's just role-based, whether it's anything at all, and just upload it as part of the network configuration. And now the student gets to look at a visual representation of what they're looking at. For most labs, it's a few VMs on a single segment. But when you get into things like this, I think this becomes particularly useful, and particularly important.
Absolutely. And actually, this was a huge help for me just in building out this lab, because being able to draw out the diagram first of what I wanted and put the details on it just gave me a spec to build to, which made it very, very easy for my work when I set this up. So and this is small, the size of this particular image, because I'm running in my laptop on full screen. But the basic notion of what you can see here is I've got two Windows VM, one on the left, one on the right. And each of those VMs is connected to a router. And then those routers are connected across this network. And there's two paths. There's a path on the top that has two routers in the middle, and there's a path on the bottom that has one router in the middle. And so it's set up out of the box that these virtual machines can talk to each other, and the network is configured so that they're going to take shortest path. So when one pings the other or talks to the other, it'll go over this bottom network segment or series of segments. But then you can do cool things like build fault tolerance. So I have an upper redundant network segment that's there to pick up if, for example, I cut the bottom segment out of the picture. So let me show you how that works. First of all, I'm on my Windows box, Windows 1, which is the one that was on the left-hand side. And I can see the computer name. Whoops. So it's just called Windows 1. And I can ping 192.168.2.2.
And this is the one all the way on the other side.
That's right. So this is going across three routers because it's taking the shortest path to actually get to that box. And it's responding to ping because my network is properly connected.
Are you going to trace route it too?
Yes, absolutely.
Oh, I'm sorry, I'll just stand there.
So before I get to traceroute, I was going to show that I can even, because I'm a PowerShell guy and I can configure this stuff, I can enter a session with that remote system and I can check the computer name, and my computer name I'm on now is Windows 2. So that just shows that I'm properly connected and then I'm not just...
us non-PowerShell guys would have just typed host name, but I'm sorry, that's just me. I'm old school.
Yeah, that's right. But it's not all smoke and mirrors. I'm actually connected to a remote box, and you can see the IP address and the name. And I can do trace route to 192.168.2.2, and you'll see it's going to take a second here while it figures out its way across the network, and it'll show me the hops along the way. So the first router, the IP address, the second, the third, and then the end system on the other side.
And everything in here is just in the lab.
That's it.
Just a lab.
Yep, just working with virtual machines. And I can also go to the other side, of course, and I can do all the same things. So I can come over here and trace route.
So you're on the other side of the.
That's right.
That was the fastest flight ever.
Exactly. I wish my flights were so quick. And I can go to .0.2, which is the IP address of Windows 1, and I can trace route back. And it's going to take a second again to find the network. And there it's gone and finds the proper routers and gives me my trace route between the two. So that's really cool. And then because I showed you in the network diagram, going back to that for a second, there are two routes. So that was going over the bottom. And I've configured each of the virtual routers to do proper routing for the IP addresses it receives, to forward it in the right direction, and set up the actual distance between the routers so that it's smart enough to figure out the shortest path. But what happens if this MikroTik 5 router on the bottom disappeared? What happens if the connection to that one drops? Would my VMs still be able to talk to one another? So I talked about MikroTik 5. Now we're going to double check, make sure that's the right one, because I don't want to take the wrong one offline. Yeah, so I've started them, I've numbered them. 1 is on the left, and then 2, 3, 4, 5 in clockwise order. So if I go to MikroTik 5 on the bottom, when I click on that, I mean, you just see a black box, but that's because it's in power saving mode. I just hit enter and I get my screen, so I can actually see them.
So this is the actual router OS for this little emulator router you're using.
Right.
And we can use, obviously, this particular emulator router is one that we've had some success with.
Yes.
And it's easily configurable, very reliable. So it's good, basically a good router to use in these scenarios.
I think so, yeah.
But this is obviously not the only option, right? There's, if you can run it in a VM, we can do it here.
For sure, yeah.
Or even if it doesn't run in a VM necessarily, because we can emulate hosts with nested virtualization now. So we can run on a Windows or a Linux box. If it's Windows or Linux based, we can do it in here.
Yes.
Okay.
Absolutely. And so these routers use when you're on the box itself, they just use command line access. So I can, if I do print here, I can see the routes that I configured. And this is really small, and I apologize for that, but that's because it's a hardware device that has a default resolution of 640 by 480.
So a default resolution of 1992.
That's right. And of course, no options to right-click set my display settings and configure that to blow it up bigger. But at any rate, this gets me onto the box, and I can see the hardware, and I can add additional routes or reroute things. But in this case, I want to draw your attention to the right-hand side here. So inside of this lab environment, if I look at my Windows box, for example, you can see I've got one Ethernet adapter, and it's connected to the 192.168.0.0 segment. And I can drop down that list, and I can see all of the different segments that I set up inside of my environment.
So you can basically plug and unplug cables here.
Yeah. So
I can pick up the machine, and I can say, you know what, I'm going to put this on this segment here. And so there's interesting scenarios there where we can say, hey, you're a troubleshooting guy, and you're in your box right here with all your tools, but the router upstream is broken, and you work out that you can't get to it, so now you've got to go plug into the router directly. LOD lets you basically do that. So you can lift your machine off of your company's network, and you can virtually walk to the ISP and plug it into the ISP's network directly to troubleshoot or fix problems.
Which is really useful too if you're less of a command line guy. Like, so I mentioned I love command line, and I can go in the routers and I can run the commands. But this particular router, MikroTik, they also have this tool called Winbox. And so if I open up Winbox on my Windows system here, and I've got the address of the first router that it connects to, I can just hit connect, and now I can go in and I'm looking at the router configuration.
And so this is just part of the tool set that comes with this?
Yeah. Okay. So in this case, I'm just using a GUI instead of using command line to work out stuff. So I can.
How's that working out for you? I mean, I know that's hard for you.
I got to tell you, I so prefer the command line to working with the GUI. I know. I'm not in the majority with that, but anyway. So in this scenario, you could have, I got 2 Windows VMs and I'm working with connectivity. I could have my admin Windows VM that I unplug from one router and go plug into another, because I can't, from this particular box, connect it to a router that's a few segments deep. I can't get to that point. So I'd have to unplug and plug in somewhere else, and this lets you do that virtually inside of the lab.
Awesome.
Yeah, and so talking about changing these Ethernet connections, I'm going to go to that router 5, which has two network adapters, 1 and 2, and I'm just going to unplug them.
You're just going to break it. So
Yep,
so some guy tripped in the cable, yanked it out of the router, router's down. Oh my God, the internet's broken.
that's right.
Okay.
So I just unplugged those two guys, and now I'm going to hop back onto my Windows 1 box and go back into my trusty PowerShell session. And now, if I ping, I want to make sure I still have connectivity. 192.168.2.2, because I'm going to the right. And
Is this the part where we cross our fingers?
yeah, this is where we cross our fingers, and it looks like it hasn't picked up on it.
So what normally happens here?
So what normally happens?
There you
There
go.
it is.
Yeah.
So I found it. It takes a second, of course, when you unplug stuff and it's trying to figure out how things go. It takes a second for it to reset the routers and make sure that they're going to go in the right direction. And so yeah, so I just unplugged my routers on the bottom, and it still found its way on the top. And if I run traceroute, .2.2, now. And you'll see both. You can compare this with the one that's up here,
Yeah, so
higher on the
we can
screen,
see
right?
the top one here.
Yeah. So it's gone a different path. It's gone to the 10.02, 10.
And it's a 3-hop path now.
Yeah, yeah. So there's one extra hop, right? Because I talked about shortest path. So by default, this lab environment was configured to take the bottom path, but you cut the cables, and all of a sudden it has the fallback fault tolerance path.
So could I use this for, like, just thinking of scenarios? So I'm load balancers, right?
Yeah.
So I want to do a database app, web app, and I got 3 web servers in front of the database, 3-tier, 2-tier application, and I want to do an environment where I have to build something that's highly available, even like a cluster, and I want to legitimately simulate hard failure.
Yes.
Not going into the VM and like turning off the connection, because that's not the same thing. I want to yank the cable.
Yeah, absolutely.
This lets you do that.
Absolutely.
What about, I want to configure remote access. I want to go from inside the firewall to outside the firewall.
Yes, so these routers have firewalls, and so you can configure your ports. And I mean, so this one has it as well as pfSense. They have a firewall, and so you can configure the access on these routers and set that up so you could block traffic or turn
And
traffic
then I can move a VM from like one side of the firewall to the other side of the firewall.
Yes, because you can unplug and replug and move things around.
Just by changing the network interface.
Yeah, which is really awesome. So I've been having a lot of fun with this lab.
I would imagine. So that's pretty phenomenal. Now the routers did you do anything special for them to auto reconfigure the routes, or is just turn on RIP or OSPF? I was a CCNA way back in the day, so those are the only 2 terms I remember: RIP and OSPF. BGP, I remember that one too.
Yes, so BGP is in these routers as well. So if I go to this environment and I look at my route tables, I got to go print detail because I forget the name of the switch. Yeah, there's this check gateway. So I've got check gateway ARP set. And so what I did is after I configured the distances, so it knew which was the shortest path and longest path, I also turned on check gateway on the shortest path so that if that's going to fail, if that fails a ping, it'll just take a second and all of a sudden reconfigure and reroute to the longest path. So there are options in this particular router for how you set that up. And I just did it via the command line.
Is there documentation for this thing?
Oh, there's great documentation for this thing. There's lots of examples, there's scripts, yeah.
Where do we find that? I mean, aside from the Google.
Well, I mean, so Google's how I discovered it, but they have a wiki and they have communities and people asking questions. And so, yeah, I Googled to get into it, but once I was in it, then you can poke around and go through their wiki, and there's a lot of rich documentation there.
This is strictly an opinion question. I know we don't plan this, by the way. We just do this. Someone that was doing, say, CCNA, have you played with Cisco's emulated environment, and will that run on our platform?
So I have not played with it directly myself, but yes, I know that there are Cisco's emulated environment that people have set up. There's one where somebody set it up in nested virtualization on a vSphere system. But yes, there are people who do that already.
If someone's doing just general like networking, even just learning Cisco, I mean, is this comparable to what a Cisco iOS interface would be? It's iOS for Cisco still, right? Yeah.
I don't
As opposed
know.
to iOS for Apple, I still think it is. Someone knows.
But this is very comparable. When I was talking to Nick, one of our guys who works in our data center, and great resource. And so he, when he was looking at this, he said this is just like old Cisco routers, and yeah, very comparable.
Awesome. Okay.
Config and setup.
Excellent. Thank you.
So how do you get to this point? And building this lab, and one thing I got to say about this was surprisingly easy. The MikroTik router that I picked, they have a VMDK and a VHDX file available for download on their website, and I have a resource slide with some links later on pointing to that. And so I was able to just download the virtual hard disk and then add the virtual hard disk to each of my MikroTik VMs, and there's 5 of them. And because we used different sync disks, it was that was it. It was that simple. Like, it was just adding it in and turning them on.
This this particular lab environment right here that you've built as a sample, is that something we can make available on our blog for people to play with?
Yes, for sure we can.
Okay, we'll look at doing that when we're done, because I think folks would want to go in and kind of mess around with this and just kind of see what they can do. Just publish this on our blog as something you can go play with for a little while. I think that's a good idea. So we'll look at doing that. That'll be great.
And there's a few things I'll point out in terms of how this is set up, so you can see if you were to look at playing with this yourselves and wanted to see how these kind of things can get set up in a lab. So I'm going to jump out of my lab environment.
Yeah, so let's look at how you build it in LOD now.
That's exactly right, yeah. And so this is my LOD.
Can you, up your screen, you can like zoom in on your screen?
Yeah,
so
I'm just going to do Control-Shift+.
Yeah, let's go, make it nice and, there you go, a little bit, there you go, let's do that. That should be a little easier to read.
Yep. So this is my virtual networking lab, and inside of my Skunkworks sandbox that I play in. And so what I have set up inside of here, let me just jump into Edit. I'll show you. So aside from the basic configuration and setting up how much memory and whatnot.
And so by the way, this is all the stuff that Brian's doing in his track today.
Yes.
Is how you do the basics of building a lab environment.
Right. And so once you get beyond the basics, then you get into some of the configuration things you need for this sort of networking to work. So if I go over to the networking tab, you can see here I've got my link to my lab networking diagram, which I uploaded. And so you just add that to your networking tab.
Did you just draw that in Visio or something?
Yeah, I just used Visio.
Okay.
And Visio, I mean, it was pretty, and it took only a couple minutes, and that was it. It was really easy.
Well, you think it's pretty.
I liked it anyway. And so, yeah, so that you upload a networking diagram, and then I have a bunch of private networks. So these are just virtual switches, Hyper-V virtual switches I'm configuring for this particular lab. And I set them up as private because I'm just working offline. And I named them with each of the subnet addresses for that network, because that makes it very easy once I'm inside the lab, especially since I have a networking diagram built.
I do want to clarify that point, though. When you put 10.0.0/30, you're just naming the network.
Yes.
The IP configuration is done within the lab itself.
On the router, yes.
I don't want someone to be confused and say, oh, if you put this here, then it'll pick up these IP ranges. That's not how it works.
No.
You're just using these names just so it visually makes sense, right? You could have called this network 10/30.
Right.
Or anything you want.
This is like the sticker on the network cable, so that I know when I unplug something and I plug it in somewhere else, I can see that
And the fact that it's visible to student is what gives you the drop-down.
Yeah.
Okay. This is not something that most folks normally ever look at or play with, is this notion of visible to student.
Right.
So that's what makes the drop-down appear.
Yeah, and so I just configured each of these. You can see this little checkbox, visible to student, and I configured them for the ones I wanted people to be able to actually see. And so I've got a bunch of those network segments defined. And then at the bottom, I've got just an internet, basically internet web access in case I needed it, which turns out I did not. And so that's kind of the network setup. I can just come down to the bottom if I would need to add another one, and just add it the same way I add all the other ones. Just define it as a private network, define the segment IP, which is putting the label, as you said, and then my networking's done. And then if I go to my virtual machines, and I look at the details inside of those, so now I'm working on the virtual machine. Okay. And by the way, a few things I want to point out with this. So when you're dealing with the networking lab, I configured all of my routers to start up first and my Windows VMs to start up 30 seconds later, just because I wanted to give time for the network to get alive first.
And that's actually a good point that, we support the notion of a save state. So you can just resume from save state. And generally, if you're running, Windows or Linux operating systems, it's quicker to start from save state than wait for things to boot. But there's not all scenarios where save states are just a good idea. And one of them is certainly these kind of router devices that, they don't take that long to boot, do they?
Oh no, they boot in
seconds. It's like 10 seconds?
Yeah, or less. It's quick.
So for some of these, it's just better to let them boot.
Yes.
And so what you've done is said, okay, all these devices that are, that have dependencies, we're going to wait until the devices that depend on are ready. And so you're just saying boot the routers first, wait 30 seconds, and then boot the Windows VMs.
Yes.
And so when you look at like a lab start time, that's going to be a longer lab start time, but you're structuring the start so it's more successful.
Yep. That's exactly it. And also, the other thing I did is I configured these with static MAC addresses, which is an important thing to note because if you don't, then the routers, the way that they pick up the different MACs, if their MACs are changing all the time, every time you start them, you have to reconfigure them. Yeah. But by going to static MACs like they would have in the real world,
and our general recommendation in labs is use static MACs whenever you can anyway.
Yes.
Because there's all sorts of things. If you've got networking in a lab, If you just constantly swapping MAC addresses, then Windows will see it as a different network adapter. Linux might see it. The IP might change. DNS resolution might break. Static MACs are by far and above the recommendation for any network adapter you put in anything, with the exception of adapters that you want to have that are directly connected to the internet, right? That are going to pick up IP addresses via DHCP. Those, if you do static, you have MAC conflicts.
Yep.
But anything that's a private network, certainly a static MAC address is the recommendation to use. Now, did you generate your own, or did you just let the system generate it for you?
So the system generates for me. So I just click on this checkbox, and it'll automatically look at the lab that these VMs are in and grab an available static MAC address that's not already taken. And that's great. I don't have to think about it, right? I just click on that, and if I wanted to change it, I can click on generate, and it'll go and regen. But I just let that go and pick them for me. I didn't have to draw up my own list and configure that manually. So each of the network adapters, like this is just inside one of the VMs. Even on the Windows boxes, I set up static addresses just because it works better.
Yeah, static addresses are always better in labs. Macs, IPs, you name it. They're always, when you can use them, it's better.
Yeah. And that's pretty much it. So that's a Windows box. Now I'm just going to go back for a second. I want to jump into one of the, one of the MikroTik boxes. And so these guys, the way I set these up is I just took the virtual hard disk file that I downloaded from the MikroTik website, and then I uploaded that into storage, and then I built a new VM on top of that.
And you added 3 adapters to that VM, I see.
Yeah. So if I go into my edit options, and I go into, like you can see the hard disk, and it's building off of this base system. That's the one I pulled down from their website. And then if I go to my network adapters, I've got each of my network adapters configured, 1, 2, 3, and then I plug those into the various switches.
So let's go back to the page where you plug them into the switches. I want to see that real quick.
Sure. So back out here.
Right, so right here, so this is the 3 adapters in the VM, and those drop-downs are the networks you've defined.
Correct.
And so it makes it convenient for you can see, okay, the network adapter 1 is on this subnet, this subnet, this subnet. And then once you've got them on the subnet, you've got to go in the VM and set the IP addresses.
Yes.
Okay. And that procedure obviously varies depending on Linux, Windows, router emulator, whatever.
Yes, that's correct. Yeah, so yeah, I can just drop this down and I can see all of the different networks that I made available and then set them as I needed to according to that network diagram that I did. And I mean, adding a new one is literally a matter of a few minutes because I just add a new VM, I hook in the VHD, I add a couple of network adapters and plug them in, and then I can fire up the lab.
So can we go look at your diagram for a second?
Yep.
It should be right on top of the screen. It's right on the network tab. So over the network tab's your diagram. So what you did is added 5 MikroTik router devices.
Yep, that's right.
But you could add another 100 of these, I mean, if you wanted to.
Right? Oh yes.
I mean, you could. How much memory do each of these MikroTik devices take up?
So I didn't check the base system. I just threw 1 gig in each of them. That was fine. I don't even think I need that much. I know I've worked with pfSense, which I can launch with 256 megabytes of RAM. No problem.
pfSense is what is that?
That is another router that has firewall, that has DHCP, that has VPN. And so, yeah, so pfSense is just another example. That one I've launched with 256 megs, and it works just fine. These ones, I just quickly threw in a gig, but I don't even think that they take that much because they don't have much demand.
So at some point, too, I think what we'll do is we'll do some guidance on this. Say, okay, here's the routing lab that we built. Here's the devices that we use, and here's kind of our recommend configurations for them.
Yes, that's a good idea.
And we'll post that up, and folks can download it and kind of get an idea of, well, if I want to do this for myself, how would I do it? Because I think there's some really interesting scenarios in here where you can maybe have a router in the middle, and now you've got all sorts of redundancies. And then can these things, I don't know if you know or not, but can they do like traffic saturation simulation? Or, I want to simulate a link that's not down, but maybe overwhelmed.
I don't know that one. I'd have to look into that. Yeah.
But I know there's software you can get that can do that.
Yeah.
So there's theoretically ways to do that too. We can say, hey, segment 4 up there is maybe just too much stuff, right? There's a new Netflix movie, and it's just saturated. So do we dynamically reroute? And I think that just comes down to how creative you are as an author, a designer, and then how you leverage the capabilities within these devices you're running.
I haven't tried watching Netflix inside one of our labs yet.
I have. You can't.
But at any rate, I mean, this is a nice bigger picture of the diagram. You can see that I just ended up showing what all the IP addresses are. Each of those are based on the network segments that they're plugged into. And then when I plugged in my switches, I just looked at this to see which connections I had to plug into and plug them in, and that was it.
Yeah, that's a good point. Someone mentioned you could simulate a DDoS attack against a router and see how everything responds, and you certainly could do that.
Yes.
And in fact, when we talk about our cyber ranges, these sorts of scenarios become very prevalent in cyber ranges, where you've got attackers, defenders, and a mesh of network devices in between. And how do you keep that alive? And so certainly this this dovetails into that very, very nicely.
Yeah, I agree. I totally agree. When we were talking about cyber range earlier, and I was thinking, since I've been playing with these, that this would be really cool for those scenarios for sure. The other thing I wanted to show, and I'm just going to jump back briefly into my lab environment. I talked about nested virtualization, but I didn't show it. So inside of this particular lab, I have my Windows boxes and I have my MikroTik boxes, and let me zoom back out again, because I don't, 1 second. So yeah, I have my Windows VMs and I have my routers, and then at the bottom I have this host box. And this host box I didn't even show in the diagram because really it's not doing anything. I just put it in here because I wanted to talk about the example of nested virtualization. So what I'm working in right now is a virtual machine running Windows Server 2016, and inside of that virtual machine I have installed Hyper-V, and I can open up Hyper-V, and inside of here you can see I've got MikroTik-1, MikroTik-2. In this case we want to zoom in a bit. Oops. If I can. And so, now it's not letting me zoom in. But at any rate, I've got 5 different virtual machines in here, 2 MikroTik routers, 1 pfSense router, 2 Windows VMs, similar names to what I have at the higher level, but the names don't matter. This allows me to run virtualization 1 level deeper, and I wouldn't need it for some of the things that I talked about inside of that network, which is fault tolerant that I built, but I would need it for things like Open vSwitch, which has to install on a host, and I installed that here, and it installs just fine. I haven't gone to the point of configuring that yet, and I haven't gone to the point of seeing what I can do with OpenStack.
The point being, you've actually had virtual machines running in virtual machines.
That's exactly right.
And that's a whole other realm of scenarios that you can apply to this.
Yes. And configuring it is actually really easy. If I go back to my setup and I come back into my lab again, if I look at the basic information for my lab and I scroll down to the bottom.
It's on the VM.
Oh, that's right, on the VM tab. Thank you. So I got to go down to find my virtual machine at the bottom. So here I've got this host VM, and I can jump in a little closer. And so if I look at this guy and I go to Edit, now I'm going to scroll down to the bottom of this tab, and here you can see Enable Nested Virtualization, and it's just a checkbox.
Yep. And all that does, it injects the appropriate instructions in the VM to turn on nested virtualization.
Yes.
So now you can do things like install Hyper-V, or in the case of vSphere, install vSphere in vSphere, or VM, or it's ESX. That's what I'm looking for. Install
That's
ESX
right.
in ESX. And then once you do that, I mean, the world's, the sky's the limit in terms of what you can do.
Sure.
You can install, OpenStack. You can install, really anything you want. Build, your lab could be, 10 VMs, or it could be one, 50 gig VM running 10 VMs.
Yes.
So just that level of flexibility goes up. Now, the one thing I will say about nested virtualization is, every layer deeper you go. Have you ever seen what was the movie? Inception. Every layer you go deeper, the slower things kind of get.
For sure.
Right. So if you start nesting, there's just so many layers you've got to go through that you start to take a performance hit whether you like it or not, right? And so nested virtualization, 1 layer, you'll see it. 2 layers, it starts to get clunky. 3 layers, you go no. So certainly something to keep in mind with that.
But the VMs work, and I mean, you can still
absolutely.
set up the lab environment, and it's fine. You just need to, you have to understand you're going 1 level further out, and so that level of abstraction.
There's also there's a usability concern too, I think, for students.
Yes.
That you tell them, in the VM, it starts to get a little bit difficult to figure out where you actually are.
Right, because if I go back to here, for example, you don't see these are top-level virtual machines, but the virtual machines inside of my VM that is a hypervisor don't show up at that level, so you have to go in there, and so that also
it does. I've built some labs that leverage this, and it does get a little confusing after a while.
I totally
Even
agree.
me as an author, I'm kind of, wait, where do I do that? Is this the top, second, first level, third level? And you get to these north, south, east, west conversations. It just,
But a few tips when you do set this kind of thing up, if you do play with it, just make sure you configure your system appropriately. So sufficient number of processors for virtualization and RAM. And then another thing I found useful with this is if I'm installing a bunch of different things, what I like to do is I like to take my ISOs and my EXEs for installers, load them into a virtual hard drive, and then upload that, and I can just attach that to my host. And then all of a sudden I have access to all of that, so I can install inside of each.
And so like a lot of these best practices are things that Brian's covering next door right now.
Oh, good.
And so over the course of the day, he'll be covering a lot of those things. So
Okay.
you can certainly watch that live. We prefer you stay here. Or you can watch the recordings.
That's right. So that's kind of in a nutshell what I wanted to go through. I'm curious if there are questions. I've been watching the screen and I haven't seen anything come up specifically just yet.
Well, in all fairness, I think of all the topics we're doing today, this one is the geekiest.
I think so too.
So certainly one of the more advanced topics, one of the geekier topics. But I mean, if you're in the the security business, we talked about in our keynote the idea of a fabric administrator, configuring these lower level things, whether it's your routing and switching, storage, nested virtualization. This all becomes pretty relevant to you. So certainly great information. And so thanks for sharing it.
Oh, my pleasure. I had a lot of fun building it, so thanks for asking me too.
So that's it. That's our look at switching and routing in LOD. Give you an idea of how you can build those different scenarios. Work out different ways of installing virtual routers and switches. Appreciate you joining us. We're done. We're going to be back in about an hour, and our next topic is, if I recall correctly, is it GitHub or?
No, CyberRange is next.
CyberRange is next. So if you like this, you'll love CyberRange. So we'll see you then.